Hello, and welcome to another episode on the Total Space Network. I'm Mikko, the host of Deep Dive Fridays. Today we are talking about the return to Venus. Last year, Venus got into the news with the possible phosphine findings, and to get a definitive answer, we need some science on Venus. By the way, we had an interview with Dr. Graham Lau about phosphine, so check out that episode after this if you haven't. There's been some talk about Rocket Lab going to Venus, and they may actually be the fastest way to get there, but now we actually have 3 major missions going to Venus. Let's go over a few key questions why Venus still needs to be explored. Despite being the same size with Earth and both located in the habitable zone, and Venus possibly even hosting life at some point in its evolution, why did Venus end up being scorching hot with toxic atmosphere featuring sulfuric acid-rich clouds? Did Venus develop an uncontrollable greenhouse effect? Is Earth on the same path? Is Venus still geologically active, or was it habitable, and did it host life? Let's start with the European Space Agency mission called EnVision. It's ESA's next medium-class science mission. In short, EnVision will provide a comprehensive view of the planet from its inner core to upper atmosphere to determine how and why Venus and Earth evolved so differently. EnVision will try to answer the big questions with its sensor suite. It has Venus Subsurface Radar Sounder, SRS, which will reveal underground layering. SRS will search for subsurface material boundaries in various geological terrains that include impact craters and their infilling, buried craters, tesserae and their edges, plains, lava flows and their edges, and tectonic features in order to provide stratigraphic relationships at various depth ranges and horizontal scales. Venus Spectroscopy Suite, or VenSpec, will study the atmosphere and surface. The suite will consist of 3 channels: VenSpec M, VenSpec H, and VenSpec U. VenSpec M will provide compositional data on rock types. VenSpec H will perform extremely high resolution atmospheric measurements, and VenSpec U will monitor sulfurate minor species as well as mysterious UV absorber in the Venusian upper clouds. This suite will search for temporal variations in surface temperatures and tropospheric concentrations of volcanic gases indicative of volcanic eruptions. Venus Synthetic Aperture Radar, VENSAR. This NASA-provided radar will image and map the surface. In addition, a radio science experiment will probe the planet's internal structure and gravity field, as well as investigate the structure and composition of the atmosphere. All the instruments will work together to define the interaction between the planet's different boundaries, from interior to surface to atmosphere, providing a comprehensive global view of the planet and its processes. Launch for EnVision is planned 10 years from now in 2031, with a planned life of 4.5 years. Currently, the spacecraft is planned to reach orbit of Venus in 2033, starting a long aerobraking maneuver that extends until 2034. And as a side note, feel free to listen a previous deep dive about aerobraking. Next up, let's go over the NASA duo of Discovery-class missions headed for Venus. The big mysterious questions are the same: what happened to Venus? First up is DAVINCI Plus, or Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging. This mission consists of a probe and an orbiter. This mission would be the first mission to go into the Venus atmosphere since Soviet Vega probes in 1985. DAVINCI Plus will measure the composition of Venus's atmosphere to understand how it formed and evolved, as well as determine whether the planet ever had an ocean. The mission consists of a descent sphere that will plunge through the planet's thick atmosphere, making precise measurements of noble gases and other elements to understand why Venus's atmosphere is a runaway hothouse compared to Earth's. In addition, DAVINCI Plus will return the first high-resolution pictures of the unique geological features on Venus known as tesserae, which may be comparable to Earth's continents, suggesting that Venus has plate tectonics. DAVINCI features the following instruments. On the descent probe, DAVINCI Plus's Venus Analytic Laboratory instruments will provide high-fidelity synergistic measurements throughout the probe's descent, particularly the upper clouds and the unexplored near-surface environment. While design is based on the sample analysis at Mars instrument on the Curiosity rover, which measured the chemical and isotopic composition of the Martian atmosphere and found the first definitive evidence of organics on Mars. There is also Venus Mass Spectrometer, or VMS, which will provide the first comprehensive in situ surveys of noble and trace gases at Venus, and has the capability to discover new gas species in the Venusian atmosphere. Venus Turnable Laser Spectrometer, VTLS, will provide the first highly sensitive in situ measurements of targeted trace gases and associated isotope ratios at Venus, addressing key science questions about chemical processes in the upper clouds and the near-surface environment. Venus Atmospheric Structure Investigation, or VASI, will provide measurements of the structure and dynamics of the Venusian atmosphere during entry and descent, providing context for chemistry measurements and enabling reconstruction of the probe's descent. Venus Descent Imager, or VENDI, will provide high-contrast images of the tesserae terrain at the descent location. On the orbiter, a multispectral camera will image the planet in the UV and the 1 micron near-infrared band with a wide-field camera giving global coverage. The imaging will be done during 2 Venus flybys before the probe deployment, followed by an orbital remote sensing phase to complement the descent probe. Preliminary launch date for DAVINCI Plus is around 2029 to 2030, with the atmospheric entry in 2031 or 2032. Landing site for the probe is Alpha Regio. Second NASA Venus mission will be VERITAS, Venus Emissivity, Radio Science, INSAR, Topography and Spectroscopy. VERITAS will map Venus's surface to determine the planet's geologic history and understand why it developed so differently than Earth. Orbiting Venus with a synthetic aperture radar, VERITAS will chart surface elevations over nearly the entire planet to create 3D reconstructions of topography and confirm whether processes such as plate tectonics and volcanism are still active on Venus. VERITAS will also map infrared emissions from Venus's surface to map its rock type, which is largely unknown, and determine whether active volcanoes are releasing water vapor into the atmosphere. And the instruments on VERITAS are Venus Emissivity Mapper, or VEM, is designed to map the surface emissivity using 6 spectral bands in 5 atmospheric windows that see through the clouds. VEM also carries 8 atmospheric bands for calibration and detection of near-surface water vapor. Venus Interferometric Synthetic Aperture Radar, or VISAR, is designed to generate global datasets for topography and SAR imaging at 30-meter resolution with targeted resolution at 15 meters. It will create the first planetary active surface deformation map. In addition to these 2 instruments, the spacecraft will also carry the Deep Space Atomic Clock 2 as a secondary payload. The Deep Space Atomic Clock 2 is the successor to the Deep Space Atomic Clock payload flown on the orbital testbed satellite in 2019 and is intended to provide highly precise timing for deep space missions. Planned launch date for VERITAS is 2028 with a proposed mission life of 3 years. So that will be about 10 years before we hear from any of these missions. By the time of any of these missions reach Venus, Rocket Lab may have found out if there's life on Venus, and Starship may have done a flyby of Venus on the way to Mars. We may even get the Mars samples from Perseverance rover with the same timeline. Also, not forgetting the more obvious goals like landing on the Moon and Mars. What do you think? Is the wait too long? Write in the comments. And personally, I would of course want to see the results right now, but the space agencies know what they are capable of with their current budgets, and each one of these missions are very exciting and will give us a lot of insight into Venus. And if you like what we do, like, share and subscribe, and maybe even think about supporting us over at patreon.com/totalspace. Thanks for watching. I've been Mikko, the host of Deep Dive. See you in the next one.